In the past, we've demonstrated that winter triticale or Italian ryegrass can be successfully intercropped with a forage barley or oat. The forage cereal is taken for green feed or silage, and its quality is actually improved by including the green growth of the perennial cereal. As a bonus, the winter triticale or Italian ryegrass continues to grow after harvest to provide some ground cover and fall grazing. Some might consider this a form of regenerative farming because we are providing ground cover into the fall. In our current study, we wanted to compare how well this approach would work if the oats were harvested later for milling. When harvested for milling, the perennial cereal will have less time to regrow in the fall. However, I intend to direct combine the oats and cut them above the winter cereal. This means I'll be leaving a very well-developed cereal crop for fall grazing. I'm also interested in determining how the intercrop will affect the yield and quality of the milling oat. The objective of this study is to compare the efficacy of intercropping winter triticale, fall rye, or Italian ryegrass with a forage oat, i.e. haymaker, versus a milling oat, i.e. C.S. Camden. Let's see what happened in the end. Let's take a closer look at the treatment list, just to make sure everything is crystal clear. Treatment 1 is C.S. Camden monocropped, and treatments 3 to 5 are winter cereals intercropped with Camden. The Camden was harvested from all these treatments for grain in late August to early September, depending upon the location. Treatment 2 is monocropped haymaker oats, which is a forage variety. Treatments 6 to 8 are winter cereal intercrops with haymaker. All of these treatments were harvested earlier for green feed, around mid-August. The winter cereals used were fridge winter triticale, Italian ryegrass, and fall rye. By early to mid-October, grazing yields were taken from the regrowth of the winter cereals. Intercrops of spring and winter cereals were seeded at a rate targeting 225 plants per meter squared, except for the Italian ryegrass, which was just seeded at 10 pounds per acre. This study was conducted at the following AgriArm sites in 2024: Melfort, Redvers, and our site here at Yorkton. This figure shows the grain yield of C.S. Camden for each individual site and for all sites combined. There was no interaction between treatment and site, which means treatment effects were similar between the locations, allowing us to focus on yields averaged over all sites. Yield of C.S. Camden when grown alone in blue was significantly higher yielding compared to intercrops with fridge winter triticale in orange and fall rye in yellow. While the seeding rate of oats in the intercrop is cut to about 3/4 the monocrop rate, I do not believe this has played a substantial role in the yield reduction, since an intercrop with a less competitive Italian ryegrass in gray provided a similar yield to the monocrop. In other words, the fridge winter triticale and fall rye are just more competitive with the oats compared to the Italian ryegrass. Actually, they're very competitive, as grain yield was reduced by 25%. In this slide, we're looking at grain protein. Again, a lack of a significant interaction with site allows us to focus on the treatment means averaged over all sites. It would appear the added competition from the intercrop involves competition for nitrogen, since the grain protein was also reduced by the intercrop. Again, the reduction is greater when intercropping with fridge winter triticale or fall rye compared to the Italian ryegrass. At Yorkton, lodging was also reduced for the intercrop. On a scale from 0 to 9, where 9 indicates the crop was flat to the ground, we found lodging for monocrop Camden in blue was significantly higher than the intercrops. Now, part of the reduction in lodging could be attributed to lower seeding rate for the oats in the intercrop. However, note that the lodging hasn't been reduced as much when intercropping with Italian ryegrass in gray. This suggests to me that the removal of nitrogen from the system by the intercrops is also playing a role in reducing the lodging. This is particularly evident for the intercrop with fridge winter triticale in orange. I took this picture just before grain harvest to show you the difference in lodging between the monocrop on the left and the intercrop on the right. Intercropping also had an effect on oat test weight. Below the blue arrow at 245 grams per half a liter, milling oats will be discounted. Below the red arrow, marking 230 grams per half a liter, oats will be rejected for milling. While there is no significant interaction with site, you can see test weights are very low at Yorkton and Redvers compared to Melfort. In fact, the oats at Yorkton and Redvers are below the rejection line. However, you can see the intercrops have increased test weight, particularly when intercropping with either fridge winter triticale or fall rye. Again, this comes down to removal of nitrogen by the intercrop from the system. Excessive nitrogen is well known to reduce test weight in oat. Let's flip to the green feed side, where we are growing CDC haymaker oats as a monocrop or as an intercrop with a winter cereal. This time an interaction with site was detected, so we must focus on all sites individually. The site that seems very different from the others is Yorkton, as intercrops with a winter cereal did not significantly affect yield. This can happen because the winter cereal component is contributing to the green feed yield. At Melfort, and particularly Redvers, there was a similar trend to what was observed with the grain yield results. Yield was reduced by the intercrop, but to a lesser degree when the intercrop was with Italian ryegrass. In terms of green feed quality, the protein numerically was a % lower when intercropped. Not sure I would have expected this, since the vegetative winter cereal would have been part of the green feed. Similar to the grain yield portion of the study, intercropping with fridge winter triticale and orange particularly reduced the lodging at the Yorkton site. Here are a few pictures to give you a visual. Above are 4 plots of haymaker oats grown as a monocrop, which on average have more lodging than the 4 plots below of haymaker intercrop with fridge winter triticale. Again, this is likely a function of a lower seeding rate for the haymaker oats when intercropping, along with the winter cereal taking away some of the excess nitrogen. In October, regrowth of the winter cereal was harvested to determine fall grazing yield. There was an interaction with site indicating that the results differed between sites. At Melfort, regrowth after green feed and grain harvest was relatively low and differences between treatments were not detected. At Yorkton, grazing yields were particularly high for fridge winter triticale in dark blue and fall rye in gray after CS Camden was harvested for grain. Now, at first it may appear counterintuitive that there was more regrowth after oats were taken for grain because there would be less time in fall for regrowth compared to harvesting earlier for green feed. However, when harvesting for grain, I was cutting above the winter cereal, leaving it all intact. Let me take you out to the field and I'll show you what I mean. I'll give you an example of what I'm talking about here. Here we have Camden oats that I'm going to take for milling. And below it, we have fridge triticale. Now there's a pretty good amount of fridge triticale under there. But I plan to harvest this, direct combine it, at a height so as to leave all that plant material behind. Now you wouldn't want to swath this because then I end up with green plant material growing through my swath. So it does limit my harvest options. It has to be direct combined. But you can see there's a lot of fridge triticale growth in there for fall grazing. Now compare that to the fridge triticale regrowth we have in this plot, which is considerably less, in a situation where we've taken the haymaker oats off as silage or feed. The other thing to note at Yorkton was greater regrowth for the winter triticale and fall rye compared to the Italian ryegrass. While this was very dramatic for regrowth after grain harvest, it was also apparent, but to a lesser degree after green feed harvest. At Redvers, the results were very different as the regrowth of the Italian ryegrass in orange after grain harvest and in light blue after green feed harvest gave the highest grazing yields. I'm not sure why this happened. Based on my past experience, I was not expecting the Italian ryegrass to outperform the winter triticale or fall rye. Feed quality-wise, fall rye had the highest protein, followed by fridge winter triticale, and then followed by Italian ryegrass, at both Melfort and Yorkton. However, digestible nutrients tended to be higher, and the ADF was lower for the Italian ryegrass. Here we're looking at the total forage production for the intercrops with haymaker. Green feed is in blue and grazing yield is in orange. At Yorkton, intercrops with either fridge winter triticale or fall rye significantly increased total forage production over haymaker alone. In contrast, at Melfort, intercropping with a winter cereal did not increase total forage production over the monocrop. And in contrast again, at Redvers, intercropping with fridge or fall rye decreased total forage production over haymaker alone. The difference was statistically significant with the fall rye. Conclusions. Fridge winter triticale and fall rye were more competitive than Italian ryegrass and likely removed more available nitrogen from the oats. I came to these conclusions because there were greater reductions in grain yield, grain protein, green feed yield, green feed protein, and lodging. Also supporting this hypothesis is that there were greater increases in test weights. The greatest grazing yields came from fridge winter triticale and fall rye at Yorkton, but in contrast, it was Italian ryegrass at Redvers. In terms of total forage production, at Yorkton it increased with fridge winter triticale or fall rye, and in contrast it decreased with fridge winter triticale or fall rye at Redvers. At Melfort, there was no difference. In terms of intercropping with tame oats for grain yield was reduced by 25% when intercrop with either fridge winter triticale or fall rye. That's a lot. You have to really want that fall grazing to give up that much grain yield. The grain yield, however, was not reduced when intercropping with Italian ryegrass, and maybe that's a better option to consider. The crops also need to be direct combined, which is a little concerning. Swathing really isn't a good option with all that green material underneath, and if the crop does lodge, it might be a little more problematic than normal. Another thing to add here is that the cover crop could use up valuable soil moisture for the following year, should you find yourself in a dry period. Funding for this study was provided by the Sustainable CAP program.